Hello everyone. From today, let's go on to the advanced SQL statement. Uh, we will learn new keyword in SQL. The first one is order by here. Yes. So I want to order searching result, the query result by some ordering criteria. Then we can add order by keyword in select from where clause. In this example, where clause is not used. Where clause. But if it is used, then the location of the where clause is here. So we must keep the sequence of this keyword select from, where, and order by. Yes. In here, there is no where clause. That means that there is no conditions to search here. But the result must be ordered by this criteria. The first criteria is order number. Okay, C1, criteria 1. And the second criteria is price. Okay, the data will be ordered depending on this first criteria, order number. But if there is the same order numbers in the result, then they will apply second criteria, ordering criteria, price. Okay, yes. So if we see the result, then we can see that order number is used to make orders by ascending orders. Okay, 1,000, 2,000, and 3,000. Yes, it is increasing now. So it is well done here, well ordered here. And if there is the same order numbers, then we will apply price as ordering criteria here. Then I think there is something wrong here. Yes, the price must be increasing, but in the result here it is decreasing now, so I think it is wrong here. So the correct one is 130, and this is 300. It is a correct one because in here there is nothing following the criteria here. That means that the default or implicit ordering rule is ascending. ASC is omitted here. So that means that if we do not specify ordering rules here, ordering rules is ascending or descending. Here, then it is omitted, then the default is ascending. So there is no ascending rules here, ordering rules here, then it becomes ascending by default. So the result must be 130 and then 300. What about the other ones? 2,000. Okay, 50-50. Yeah, it is the same. So either one is okay. And what about 3,000? It is 50-50, 300. Yes, it follows the ascending. No, it follows the ordering rules well, ascending orders. Okay, only this the first two lines are wrong here. So the correct one is 130, 300. Okay, that is order by keyword here. So in many applications, we need some ordering result of data. Okay, because we wanted to search the maximum data or minimum data here, then we can use this order by keyword. Okay, this is the simplest keyword order by. And let's go on next. Okay, this explains ordering rules. Ordering rules. So ordering rules are two types, ascending and descending. Okay, so ascending means increasing the data, descending means decreasing the data. Okay, so here if I use order by and the price is first criteria and the rule is descending, so that means that the data may be ordered depending on this price first. Okay, and second, if the price is the same, then the second criteria or the number will be applied as ascending ordering rules. Okay, so the result is here. 300 is maximum value in price, so 300 and 130, 50, 50, 50, 50. Yes, it follows, it keeps the ordering rules well here. If price is the same 300, then second criteria is order number 1000, 3000 here. So it also as the ascending order, increasing order. Yes, it is also correct one. And how about 130 is only one, so 1000, and 50 has 4 datas. So we can check if it keeps ascending order well or not. So 2000, 2000, 3000, 3000. Yes, it keeps well. So it is correct one. Okay. If we do not specify this ordering rules, then the default is ascending. Ascending is default. Okay, here the default sort order is ascending, so it does not have to be specified if it is ascending. Okay, that's the rule of order by. And next one is at the where clause. At the where clause, we can make a strong conditions here. So if there are two conditions, then we can combine two conditions using logical operators. This is a logical operators. So the first logical operator is AND. Okay, so both of the condition must be satisfied. That means AND logical operator. In the example here, department must be water sports, and at the same time, buyer must be Nancy Meyer. Okay, so that data satisfies only 2 data among the SKU data set here. So 2 data will be selected here. Okay, both of them satisfy water sports and the Nancy Meyer. That's the expected result. Okay, the second one is it is also logical operators, or either one of them must be satisfied. Okay, so here department must be camping, or department can be climbing. So here the data will be full to satisfy this or logical operator. This is also one of logical operators. Okay, this is either one will be satisfied. And another logical operator is in. So if there are many or operators, then we can use in operators instead of using many or operators. So buyer may be in Nancy Meyer, Cindy Lowe, and Jerry Martins. Okay, so that means that buyer may be Nancy Meyer or Cindy Lowe or Jerry Martins. So the result may include Nancy Meyer, Cindy Lowe, and Jerry Martins here. So in is very convenient to make a simple SQL statement instead of many or operators. Okay, the negative of in is not. Okay, not is a negative of in. So buyer not in means that buyer cannot include Nancy Meyer, Cindy Lowe, Jerry Martin. Exclude of these three peoples are Peter Hansen in our data set. So only Peter Hansen data set will be selected, will be searched here as the result. And also between is available in SQL statement. Between is between A and B means that the number must be between 100 and 2000. So that means that extended price must be greater than equal 100 and the logical operator and the smaller than and equal to 200. Okay, extended price must be at between 100 and 200. Okay, so we can translate or convert this between using two conditions combined by and the logical operators. Next slide, we will have it. Okay, this one, extended price greater than and equal 100. And this is a logical operators. Extended price smaller than and equal to 100. Okay, it is exactly the same as between operators. Okay, it's a very simple one here. And next one is like keyword, like. Okay, like means that it is similar to one. Okay, but this like keyword in SQL must include wildcard characters. Wildcard characters. So this SQL like keyword must be combined with wildcard symbols. But this wildcard symbols meanings has a little bit different depending on the environment. Okay, so in SQL 92 standard, which applies to SQL Server or MySQL or Oracle, then underbar means exactly one characters, and percent means any set of one or more characters. That is wildcard character meanings. In compared with that, Microsoft Access, this Microsoft Access is based on MS-DOS. In very oldest operating system, MS-DOS also has wildcard characters. In there, question mark means exactly one characters, and asterisk means any set of one more characters. Okay, so this underbar and the question mark has exactly the same meanings that represent exactly one characters, and percent and asterisk means the same meanings. That means set of character strings, but they may be distinguished depending on the usage environment. Okay, so we are going to use Microsoft Access at first DBMS, then we will use this question mark and asterisk for the wildcard characters, but after that we will adopt SQL Server, then we must use this underbar and percent symbols to represent wildcard characters. Okay, so but in our midterm exam or final exam, I expect all of you that you must use this SQL92 standard instead of MS-DOS. Okay, that's my expectations. So this one is example of a liker and wildcard character example. So here select all from SKU data where buyer must be liker and this wildcard characters. Okay, but this example has wrong here. Why? So this is the result. So I want to search some data. Oh no. This is a correct one. Yes, buyer must include pit, and it must start from pit. Okay, yes, this is a correct one. I'm sorry, I was confused with the next slide. And this one like pit, yes. Buyer must start from pit, and the following may be any character strings. Then the result is Pete Hansen. Pete Hansen will be searched. Okay, in this way, we can add wildcard character in any positions in the character string. Then we can search many kind of interesting search using this liker keyword. Okay, next example is also like and wildcard character combinations. Here, buyer and liker tent. Yes, this means that I want to search SKU data which has tent in the where in the SKU descriptions. Yes, this slide has wrong typo errors here. So correct one is instead of a buyer is incorrect here. Instead of that, this SKU description columns must be used here. Okay, because I want to search data which has tent in SKU description. Yes, here. The first example is a tent. Even though there is nothing following tent, it is okay because this percent symbols means that allows that there is nothing, any characters string is allowed here. So nothing is okay, and this one is also okay, anything, and the beginning is also anything is okay. This one is okay. So two data will be searched from these examples. Be careful that buyer is a wrong one. Instead of that, SKU description must be used here. So be careful. Let's go on next one. Next one is also liker and wildcard character examples. So this one uses one character wildcard. Underbar is here. It looks like one underbar, but actually it is two underbar here. That means that I want to search SKU data which has SKU like anything in front of 2, but following of 2, there must be 2 characters. Okay, so that kind of data will be searched in the result here. 2 is here, and the following of two characters, 1 1 1 1. Okay, and the preceding data does not matter here. Anything is okay in here. So this data will be searched as the result of these examples here. Okay, Next topic, next variation of SQL statement is built-in functions. Built-in functions. These built-in functions types are here: count, counting the number of data, and the summing all of the data, average, mean, max. So all of this data will be applied to the result set of first processing. Result set. All of this function will be applied to the result set. So this function can be called set function or aggregate function. Set function or aggregate function. Aggregate functions. Okay, so that means that this function, built-in function, will be applied to the result set of first processings. Okay, so we need some set of data to apply these built-in functions. So the next example shows that one. If we see that select the original first query is extended price from order number where order number equals 3000. That data extended price will be set maybe multiple data. Then after that, this is the first processing. Okay, first processing. This first processing will generate a set of data, and then second processing, summing the first processed data set, then it is summing here. And also they are used as a keyword. This is also one keyword to specify column names. Okay, the sum of this result will be named as order 3000 sum in the result set. Okay, so here you can see that this column name becomes as names here. So order 3000 sum made because of this as keyword here. And if you do not specify this as a keyword, then it may be empty here, or it may be empty in some DBMS, but in some DBMS it may be some temp. It means that temporary column names may be generated for the built-in functions, but if you specify it, you can use as keyword. This is also one keyword to make column names in the result. Okay, this one is the first example of a built-in function. And there may be another built-in functions like average, minimum, maximum. You can understand the meaning of this one if you see the function names here. Minimum value will be such it here. Okay, it's the same way. And count is the most frequently used built-in functions. If you do not understand the database at all at first time, then you can check how many data stored in our database, in a given database. Then you can use this count. And even you do not know what is column names, then you can specify asterisk all columns. Then this will count the number of data stored in these tables. Okay, in the result here, 7 data were stored in order item tables. And also the result are specified, the result column names are specified using as keyword. So number of rows is shown because of this as keyword. Okay, this is the most useful built-in functions, I bet, I'm sure. Okay, and also this is a little bit complex built-in functions. Count in combined with distinct here. Okay, I want to count only different department names in the data set. Okay, there may be many duplicate department data in data set. I do not want to count the duplicate data. I want to count only distinguishable department. Then you can use distinct keyword. Okay, we already have learned what is meaning of distinct. Okay, so if I have a student data set, then I want to count how many departments in our university. Then you can use this count in combined with distinct department. Okay, so in our data set, SKU data has 3 different department count. Okay, yes, it's a very useful SQL statement, so you must memorize this kind of useful SQL statement. Okay, now the next topic is it is possible to use basic arithmetic. Arithmetic means that very simple calculations like plus and minus and multiplication and division. Yes, this kind of simple calculation is called arithmetic operations. Okay, so this kind of arithmetic operation is possible in select statement. In here, these examples, like this example, yes, I want to calculate quantity times price, and the result may have as EP names. Okay, EP becomes new names of this result, this arithmetic result. And also I want to search extended price columns. Okay, from order item tables. Okay. The result is here. So you can see that original meaning of extended price is quantity times price. Okay, so the data are exactly the same. Okay, so that means that the data stored in the database are correct one. Okay, so this columns, extended price column data is stored in database, and the EP columns was calculated using also stored data, but these two data set, EP and extended price stored and calculated, must be the same in order to check integrity of stored data. If there is some data does not have the same data, the same value, then that means that either one of the data has wrong data. Okay, so this kind of techniques are used to check integrity of data stored in database. Check, integrity check. Integrity check techniques. Okay, so, but anyway, in this example, arithmetic operation is possible in SQL statement. And also string operation is also possible in SQL statement. String means that like R trim and the L trim is possible. So R means right trim. Trim, what is the trim meanings? Trim means that cut. In English, trim means cut the other things. That is trim meanings. And the right means the direction. Right trim means I want to trim, I want to cut right side of these columns. Okay, so this will eliminate, this will delete the unwanted blank. So blank will be deleted by applying this R trim at the right side. Okay, so and also this plus operation in character string means that they are combining two character strings. Okay, so buyer, R trim the buyer, and this is a single quotation mark means that character string blank in blank. They will allow only one blank between buyer and in, and also department will be integrated, combined by using this plus. So in order to be more reasonable operation here, so instead of R trim, then L trim is more reasonable operation in here, because I want to delete any blank at the left side of department. In order to insert only one blank between in and department, then I must use L trim instead of R trim. Okay, and whole result will be named as sponsor in the result. Okay, so if we see the result, spons is shown at the column names, and the Cindy Law here one blank because of this one, and after in this blank also because of this one. Okay, so this one will apply to any character string columns in here.